let us write a program. Just here we have seen single character transfer in this previous presentation. Now we will start with a complete message we will be sending. So some few character message. So just we will start. So before that, what I will do is, for serial communication related some basic part I will take down as it is. So from here to this one, how the baud rate is to be set and what are the settings for ISCON. So same thing, once again we will be using it in the another program. So I will start with project, new project, SPK say 19, save, atmel 89C51. okay, here we have to write assembly language program. So one I have shown you with embedded C, so therefore I will make it no, and now with new file we will start. So here I will just copy that beginning part. This I don't want. So what exactly we are doing, and here to send message, instead of a single character we will be sending message. Say anything. Say for example, suppose welcome SITCO. Fine. So this message we will be setting. Baud rate setting I have done once again same 4800, and we will start writing our program. From here I will write org, so I will make org 0h, then port 1 and port 2 I will be using move p2, comma, immediately will transfer. First of all I will make port 2 as input port, so for that we have to make it 00. Here itself I will write p2 input port. Fine. Then second one is move tmod setting, we will give tmod, comma, hash 20h. so this is what timer related. So our settings are timer 1, comma, mode 2, auto reload. So this is auto reload. Then next, now timer 1 th register we will have to load with the baud rate value. So move th1, comma, baud rate is 0 hash 0fa h. This is our 4800 baud rate. And next, setting for ISCON, move ISCON, comma, shift hash 50h immediately. So this is 8-bit serial mode 1, comma 1 stop, comma, REN enable, REN enabled. Next, now we will have timer 1 set. We have to set TR1. So set B, timer 1 on, start, that is we have to start timer. Start timer. Now move. Our message is that one, say, few characters are there, so we will point to that message, and for that we will be using dptr. From the code memory itself we will be taking that. So data pointer address we will point to some label. I will give, say, my data. Okay, so that is what we are doing here. Load pointer for message. Fine. And now it is, suppose we will be continuing the loop, so some label I will use. Say for example, in anything you can use. H1 I have just given for the sake, nothing, simplified some label. So clear accumulator, then take byte by byte that data. So for that move C instruction we need to use. From data pointer we are pointing, so at the rate a plus dptr, our standard practice. Get the character, now check in the loop. This is zz. Say for example, one label I am giving b1, and here condition is if last character. Get out. Okay, then equal delay, sorry, equal send. So some routine we are writing there, send. Then there will be increment pointer, increment dptr, then sjump, complete that complete loop. So here it is h1, make h, fine, enter. Now that will be b1 loop. So for that we will be writing move a comma p2, enter, equal send. Read data on port 2 and then send it serially. And as well as you can have a call receive if something is to be received simultaneously. Say for example recv, I am labeling move p1 comma, so whatever you have received from accumulator transfer it to port 1, and sjump to b1. So be in that way, display it on led or wherever you want to display. Okay, and now we will write here backspace. So for send, small routine I will write. So for send it is move sbuf comma a, then say for example h2, this loop we need to continue. So jnb based on ti status, so ti, and our target is H2, remain in that loop. Jump if not bit set, and then clear ti. You have to clear it also through software. Clear ti and return. And next part is, that is receive loop. So for that we'll write ZNB jump if not bit set RI. So there we have checked TI, and now here for receive purpose it is RI. Receive and move A comma SB wave. So whatever we are getting or receiving, save it into the accumulator and then clear RI. Return. Over. Finish. And now what is my data? Say I will say here my data colon, it is db defined by directive we are using, and message is say welcome. I am writing say welcome SITCO, fine, comma 0 is but indicating the termination, and then end. Finish. So this part is send and this part is receive. So what we are doing is, from P2 port we are taking input, and from on P1 port we are sending the output. So P1 port we are using just for the displaying purpose, if we can connect some LEDs or something for that particular character. So that also we can do here in the software, in the simulation form. We will do it with the help of our peripheral port status, and the message we will see on the in the serial window. So first of all, let me save. I will give some name, serial message. Okay, I have given serial message name dot asm. It is in machine language. So let me first of all save it. Now I will copy it into the source group. Right click, add file, serial message.asm. Just recent file, add it. Now close this window. Just first of all build it, so that if any error is there, that will get cleared. This is our file, so we'll make it build. There is no error, no warning. Now we have to debug it, so start debugging. Okay, one by one we will take the windows. So this window, serial window, we will activate UART1 window. So this I will keep here, and from peripherals I will make port 1 window. We'll keep it somewhere here, let it be. And from peripherals only port 2 window also I will activate, and that I will keep it here. Fine. So this is our serial window, this is port 1 window and port 2 window. So in send and receive we have used this, so for that purpose I am showing you. And now I will run. So here the message will appear. At present this is your termination character, just welcome SITCOE. This message we have sent, and from port 2 I have not taken any input. Now if I take it, something say this one I am doing, sorry, this is port 1, by mistake I did say here, say something like this I have done. some settings. So and now once again I will execute it. Yes, I will cross and I will run it. So actually directly here it will not show you because I'm not taking it from the receive loop. I have to make it. So here in serial window also I will make it. So we have to change here the settings. So it is arise rest, and now see here. So it will make a one by one. It will do is one, and then it is rest. So again you have to bit by bit we have to go. Otherwise, stop it and again run. So it will not be possible to see here. So it is only going to clear the port, our port 1. So this is not directly visible, this particular portion, because we are clearing it and we are not taking anything externally. So still this 69, that is whatever we have given on port 2, that is available here. Okay, so that you can see. Instead of here we are not connected anything, so we are not directly transferring also. In the receive loop, whatever is in port accumulator, that is to be transferred to after receive on port 1. Just stop, final run, otherwise I will do. And say, suppose here one more bit I will make something and run. So at present we have to enable this and then again stop, again run. Now here you can see this email, is it? So this is what you forget about. Here you can see, and message is here. So we have to give up this, stop, forget this. Here you can see port 2 setting, and accordingly that is copied into SBF. You getting? So this is the mechanism. We'll stop. Once again we will debug. And if you want to see line by line effect, so we can do that. There is a little restriction because see here. Just see. First thing, there also you can see in serial channel window. This one, this is next, 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 next. Below is your UART window. Next. Here you see this. We'll go on doing. Go on doing single stepping. Here I will show. So you go on doing. So it will stuck there because we are not changing. This code is one by one in SBF register. It is coming. So somehow we have to go to end. And this will be the message. SBF message. Fine. Not changed anything here on port 2. And if we change something on pins, again we have to pause and again we have to execute, and then cross. For that again this interrupt also we have to set and reset. So this is, and now this code is available here in SBUF register. Automatically again it is disabled from our program. So you can see here this data is copied in SBUF and this is disabled. So this is the message how you can transfer any message as far as serial communication is considered. Got it? Thank you. Thank you.